Okay, so today I wanted to talk about the flaky test. So, how many of you are developers? Okay, so pretty much everybody. So, you probably are already heard of flakiness, but according to Google, at least a blog post done by the QA team in Google, whopping 1 in 7 tests have some level of flakiness. But since you're all developers, this is probably not that news to you, right? I mean, I have dealt with the flaky test myself in my involvement with the Jenkins project. I'm sure you do the same in your day job, or else you probably aren't here in the Sunday afternoon, I mean the Saturday afternoon. So, but nonetheless, it's good to start with why the flaky tests are a problem, right? So I think the most important reason perhaps is that it creates this erosion in trust to these automations. So in my high school, the fire alarm system was broken. So from time to time, it just like goes off for no particular reasons. And from these teachers to students, they said, oh, it's just another broken fire alarm. Ignore, move on as normal. But it's like, if that was actually a real fire, then you'd see like about, the 250 dead high school students because the fire alarm was. So the erosion in the CI system, I think it's a similar effect, right? If you have too many flaky tests, what's going to happen is that people start ignoring the test failures, which is okay most of the time until it's not okay. And then you have a large fire. Unfortunately, it's probably not going to kill people, but it really embarrasses the company in front of the customers. Another reason flakiness is really a problem, especially for developers, is that it creates this really annoying, unnecessary work. And I'm sure you have done this, like, you commit the code before you headed off to the home for the evening, expecting that the CI processes kick in, like, validate things and merge and the rest of the things, except it didn't, like flaky failure happened. So later in the night, you have to log back in through VPN, only to press that retry button again. And then if that goes lucky, if you're lucky, then that goes through. But if it doesn't, then you'll be in an even harder world of pain. I'm sure every one of us here have borne some midnight oil like that. And then the other problem of the flakiness is, well, like, is that really just a flaky test problem? Or is it actually observing a problem in the production system? I'm sure you have dealt with highly concurrent, some race condition that really only happens once in a while. So your test might be actually catching those problems. You think it's flakiness, so it's a problem in the test. But if you retry until you succeed, well, next time that failure happens, it could be in production system trying to process some of these important transactions. And that's the last moment you want to see it. So there's this fear of the actual problem slipping into the production. I think that's another reason the flakiness is bad. So, as we established earlier, everybody has this problem in this tech industry. Not even Google and their highly paid engineers can escape from this problem. Right, so what are we doing about it? And that, I think, is a question worth asking. And since I work in this space, developer productivity space, I work in the Jenkins project, I used to work in the Jenkins project, and now I'm a lot more focused on using data to drive developer productivity. I decided to look at, okay, so what are we collectively doing in this industry? So one of the things that the Google guys do great, and they're also very data-oriented. So in the same blog post that they did, they correlate the sort of like a test size with the likelihood that the test contains a flakiness. And as you can see, it's got a really nice linear correlation. Again, in some sense, this is not a surprise, right? When they say tests that occupy a lot of memory, they're talking about the big integration test, end-to-end test, that kind of things. And we know, without nobody telling us, that those tests tend to be flaky. But nonetheless, when you can quantify things like that, it's really helpful because we, the developers, know, but your managers do not know. So I'm sure we always struggle, like when we say, wow, we need to fix flakiness, your manager is yelling like, blah, 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 blah. And I'm going to spend my 50% of my time working on this. That's a time you're not spending on delivering the features. So they have a hard time saying yes. But the number had a way of transcending these in the professions and specialties. So that tend to work very well. The other things that some other people have discovered about the flakiness is that there are some well-known causes to the flakiness. The one apparently is a time related. I think this is reported by the GitHub guys, and this is actually one pattern that I haven't seen before. But they said like at the end of the month or the beginning of the month or some weird, like cycles, a problem tends to, like a flakiness tend to happen. So that was that. The second one I think is, at least for me, it's a lot more common, where the test unintentionally modifies the global state. So essentially alter the state of the test system. So the next test and the test that runs afterwards, they sort of trip over to that state change that happens. So in other words, known as the test interference. So I'm sure like you had this experience when, like when you swap the test order, it just starts fading or passing. The other thing we know is that the flakiness is very unevenly distributed. So the first number I mentioned that the Google, well, actually the Google said, is 1 in 7 tests have some flakiness. But the same blog report also says only 1.5% of the test runs are flaky. And I'm like, okay, how does that make sense? Like, is that 1 in 7 or like a 1 in 100? Like, you make up your mind. Well, it turns out what they mean is 1.5% of test runs, right? So some tests fail because of the flakiness all the time, others not so often, right? So collectively, they only fail like 1.5%. GitHub reported the same thing in a little different way. That's more sensible. So they said in the given time frame, so let's see, so what is this? About the 24% of the tests have seen fading because of fakeness more than once. There's only like about 0.3% of tests that's shown more than 100 times failures caused by the flakiness. So that's what's really going on. And this is both, it's a good news and bad news. It's good news because you can focus on that really tiny number of tests, and if you can solve the flakiness in those 0.3%, then you can really make a huge impact in the perceived flakiness that your developers see. But at the same time, well, it's the bad news because you can't fix all that flakiness. Like, you're not going to fix every 1 in 7 test. So what this tells us is that we should be intelligent about figuring out where to spend your effort and try not to contain and eliminate the flakiness. Actually, containing is good. Eliminating is bad, right? So given those things that we know about the test flakiness, what have we been doing collectively in the industry? Well, it turns out there's a lot of things also done. And then the good thing is that the engineering teams like to talk about these things. So without too much work, I was able to discover all these different approaches taken by the different engineering teams, all blogged publicly. It's wonderful. Kind of designed to make you feel ashamed, because the whole point of these guys talking about it is to brag about how awesome their engineering teams are. Kind of makes us feel like, okay, like I'm not even there. But nonetheless, it's like quite quite educational. So when you read about all these things, you start to get this big picture of what's going on. And I sort of classify this into 3 different pillars. It's kind of like 3 legs of one stool. All of these 3 things need to work together for the solution to make sense. And when I talk to the actual practitioners of the software engineering who's struggling with test flakiness, I feel like they're often trying to rely on just one leg of a stool, trying to make the chair stay stable, which is like a hopeless game. Right, so what are those 3 pillars? The one is what I call the keeping builds green. So at the end of the day, our job is to deliver software. So what the flakiness does, it's almost like frictions in your engine, right? They create some heat from time to time. So number 1 goal is to kind of keep engine cool enough to operate so that the software is getting delivered. So the keeping builds green, making sure that the occasional flakiness doesn't suddenly stop the process. So that's obviously the most important things, and that's probably how everybody enters into this space. The second one is measuring flakiness. So people often measure the flakiness by how often the engine stops, right? But if the goal is not to stop the engine, then that's probably obviously a bad way to do it. So as you try to keep the kind of engine moving, you need a different way to measure flakiness, and that's the another sort of like a key effort that a lot of engineering team takes on. And thirdly, if you're just measuring the flakiness and not doing anything about it, then you might as well not even measure it. Like, why care, right? And then as we saw earlier, like, not all flakiness are unevenly distributed. So if you can focus people's attention to the right part, and also if you can focus your manager's attention that this is a problem we're solving, then you kind of already won the battle, right? So that's what the teams are doing. I call that escalating flakiness, the human attention to the right place. So let's look at that a little more carefully. So the first one is keeping builds green. Right, so not surprisingly, I'm sure you do this again, right? The number one most common way for people to keep the builds green is just retry. Okay, yeah, the monitors is also keep retrying, so it's also, please, what have I done? Come on. Well, I appreciate it's retrying at the right place. I'm not gonna even touch it. Okay, so yeah, so just keep retries until it passes. Oh, please. Interesting. Yes, flakiness finishes that. So there's just retries happening almost at about every layer of the tools that we use. So the build tools have a retry engine. You know, the Jenkins has its own retry layer. So, the test runners have its own retry logic, so on and so forth. And I call this like a different size of the retry loop, right? So, and then there are different solutions that create a different size of the retry loop. Like the smallest one that you can think of, it's probably a test runner. So like, let's say you spend 5 milliseconds running a test, it fails. So immediately your test runner can rerun the same test in the same place, same computer, etc. But if you're using something like Jenkins, then the failure is bubble. Like the retry loop is much bigger, right? Your developers get to see that they failed, and then they schedule a rerun. It's going to probably run in a different computer, a different time. And as we know, sometimes that differentness is what fixes or like masks the flakiness, right? So you kind of need to combine these solutions. And some of the teams really went much further to tackle this problem. So GitHub and Dropbox came up with a way of like messing around with the system time before they rerun the tests, which is actually surprisingly hard. Like even in the containers, like you can't really change the system time, but they figured out how to do that cleverly. And then so if you believe, well, what they reported, some class of flakiness happens because of time problem. So the natural way to kind of shake things up is to change to a different time, or they forcibly move the work to a different VM, etc. So those things have been done. And then it also creates the difference between how, do you want the failures to be transparent to the developers, which is good because they're reducing the noise, or do you want them to see the problem, which is good because they get to see that there's a flakiness in the test, that there's this problem that need to work on. Now, the downside of retries is one that it masks the flakiness, right? And this is usually the number one reason people really hesitate to make, using logic like retry to hide the flakiness. Because if you're not measuring them, then people incorrectly assume that the tests are not flaky, and then they let the problem linger. But the another kind of key problem is like it delays the feedback because the retry count has a way of growing, right? Nobody is going to go in and say, okay, right now the retry count is set to 5, but I'm going to reduce it to 3 because that's the right thing to do. Nobody ever does that. What's going to happen is like, okay, this test keeps failing, but I know it's flaky. I'm just going to increase 5 to 7 and rerun this so that the next time it's going to pass. Right, so pretty soon, everybody keeps doing that. It's growing the retry number to like a higher number than it should be. And then when the legitimate failure happens, then that's it. If the retry count is 10, you have one integration test that takes 5 minutes to run, and it failed for a legitimate reason. And it has to spend whopping 50 minutes before a developer gets to see a failure. And the people, of course, complain that the test takes longer, but dude, like, it's retrying. Right? So that is the cost of the retries. So what else people are doing to keep the builds green? Well, guess what? Surprising, some teams are basically just ignoring the flaky test, and this might feel counterintuitive, but I actually come to appreciate what they're doing here. Right, so the teams like Dropbox and Google reports that, but they run the tests. They don't retry. They let the failure happen, and they just basically ignore those failures, especially from pre-merge, where the things are more visible to the developers. Right, so they let the code merge even if the flaky, like a test that's known to flaky, fail. And then post-merge, they're still running all these tests. Now, like those things are farther away from the developers, and then owned by the DevOps engineers or the QA team, or the people who are more tolerant, let's say, of the flakiness, or they are more equipped to handle those. So there, they sort of like do more statistical approach to the failures and so on, so they can decide if the level of the failures they're observing is okay or not, etc. So I guess, another point that's worth mentioning here is, so because I was involved in Jenkins projects, the people I often talk to are DevOps engineers, and usually these are the people who care about the flakiness, right? But they often do not see what developers are seeing pre-merge, because at the pre-merge, the developers keep retrying until the code is, the test result is okay, and then merge. DevOps engineers' domain of the delivery pipeline usually happens afterward. So the DevOps engineers often lack the appreciation of just how painful these flakiness are to the developers, and it creates this conflict within the team that's often not great. And then that was, I guess I was speaking about this psychological barrier, right? Like this people's instinctive reaction that, no, I don't want to be ignoring the flaky test failures. That feels bad. That should be worked on, not ignored, which is quite understandable. But for all the reasons or the numbers I shared, I came to think that it's probably not really practical to try to eradicate flakiness. The reason it's so painful, the thinking goes something like this. Like if you're putting developers closer to the fire, meaning like a flaky test failures, then the pain is good for them. And that's what motivates them to work on, right? Try doing that to your kids. Like a pain is a great motivator, right? So it just does not work very well. In part because the developers aren't monolithic, like it's a single person. And what often happens is, let's say when the Bob is trying to commit the code, and the flaky failure he sees is created by another developer, could have left the company like a long time ago, etc., etc. So this idea that, well, by making the pain more visible, they get more incentivized to work on, that's why, in my mind, it just does not work very well. So anyway, so that's about the keeping builds green. So the next pillar I wanted to cover was the measuring flakiness. So what most of the teams that I talk to are doing is what I call the tribal knowledge, right? Like the way they measure the flakiness is by asking the engineer who's been in the team the longest. And they kind of know, like especially when they see the failures, they kind of know, yeah, I've seen that before. This test is flaky. And don't ask me why, but it just is, right? So in other words, like not really quantitative in any meaningful way. But that's really the usual state of business in this world. And that, in my mind, it just kind of talks about the missed opportunity, right? We usually think of engineers as more like a numeric, rational, like objective, like nothing like that in reality. So, but some of the teams are doing better. And these like engineering blog posts and so on that we can see. So the usual way of computing this is that so you track what code is being tested, and then if you run the same test against the same code, and if they produce the different results, then they measure that as a flakiness. And even Google guys does it, so that makes me feel good. Okay, so if that's good enough for them, that's probably good enough for me. And in my company, like we produce the services that kind of compute these metrics and provide that to the engineers, but we do this in the same measurement. We do measure it the same way. But it also has, I feel like, the kind of very naive, simple way to do things. So as we know, one of the common ways tests fail is that some external dependencies are broken, right? Like, your network is having issues, so tests started failing left and right. So, you stop the test and you fix those, and you rerun the tests. The same code tested, again, by the same test, and now they pass, so different results. So in this measurement, they recognize a flaky test failure, but I don't think the developers should see those as flaky failures. So it's a naive way, but it does work. It's easy enough. And sometimes I think the lesson that I learned from it is like sometimes like a stupidly simple solution works well enough, which is like basically the engineering principle #1, right? But some other teams have even gone further. So this one came from Spotify, which I thought was pretty clever. So they said, the flaky test failures happen randomly. Right? So if you see, so this is tracking like different test cases run at a different timestamp. I think that's what's going on. So when you see like this one build where lots of tests are happening at the same time, they don't see that as a flaky failures, because that probably some like common cause that caused it. Right? But these like random failures here and there, these like one-offs, like they recognize that as a failure. So this idea that you should compare other tests that are run at the same time and how they fail, that seems like a like a reasonable thing, very practical thing to do. And then there's a Facebook, right? No. I really apologize on behalf of computer systems, which every time, does that not happen to you? Like every time, like I was in the airline counter and then the people are having trouble with the system there. And I feel like on behalf of software engineers as a whole, I wanted to apologize that our program is not working well. But, this is not coming back. Jesus. Okay. All right. Let's see. Yes, you can do it. I know you can do it. It was happy until a while ago. Okay, I'm tempted to start the more proper troubleshooting session, but I also feel like if I was able to keep going for 30 minutes, it probably should be able to go for another 30 minutes. Okay. No? No? Jeez. Yeah, good suggestion. I love it. Okay, all right, let's do that. Okay. All right, I'm gonna go down the lower resolution. Man. Well, let's see. What can we do here? I could try a different connector since the organizer have it here. Let me do that quickly. Well, so what's geez. Great. Best. Oh, okay. Don't touch. Whew. I don't know. Oh, come on. Oh. Let's not jinx it. Okay. I am so sorry. well, maybe this is the downside of missing an in-person conference for 2 years. I forgot how to do these things anymore. But this is not working enough. Maybe I think the I'm going to avoid full screen mode because the before this show began, that was what was tripping or not. Jeez. Okay. Okay, I'm just gonna. Yeah, that's that. It's. Oh. Okay. I tried 2 different connectors here, so it must be my computer or.
Yeah, no, you're doing the right thing.
I'd like to think so. I've been presenting more than well.
Yeah, I know.
Let's see. What would be? You know what? Yeah, I guess I'll just keep talking, and if the flickering start to get too annoying, you just maybe you can start looking at me. So what was I saying? Yeah, the Facebook. So they have some of the craziest approach that I've seen, and this is what's going to happen when you hire a PhD and then try to put them on these new projects. So they came up with a statistical model, otherwise known as the Bayesian inference. And this is a mechanism that's used by things like spam filtering and so on. It's a pretty straightforward but nonetheless interesting statistics. So what they do is that they say there are 2 reasons the test could fail. The one is the test can fail legitimately, right? Like something is bad. So whenever you run, it always fail. But even if the test code is good, let's say the failure could happen from the flakiness statistically, just by sheer chance. So they model those 2 things separately. But they say, well, the only thing we can observe is the pass or fail. We can't really, from outside, tell these 2 things apart. So if you're only seeing pass and fail, what are the likely combination of those PB and PF? And that's kind of how they go about it. And then so they could, So so that's how they can do things. And then the third leg of the stool is escalating flakiness. Okay, so the naive solutions, and I think what we are actually the naive solution that I think we should be doing more often is to just throw the test away, right? I mean okay, I know we're supposed to be fixing tests, but really, because of the nature of the testing. Do you have a professional help? Thank you. Yeah. Okay. Yeah. So I know the tests are the flaky failures. Some of those are just inherent to the problem.
Do me a favor.
Yeah.
Just put it right there. That's where the splitter is. So it's maybe.
Ah.
Yeah. It's just
See, that's what the pros can do. They see the problem for 5 seconds, they already know what's wrong. All right, I love it. Thank you. Wow, that seems like a magic. Thank you very much. Oh man, well, I guess, yeah, no. And that's always almost like what the technical troubleshooting is like, right? Like we're looking for this place, and no, the problem is over there. I love it. Okay. So say if you're doing the integration tests or like a large-scale testing, there's always some bits of uncertainty in the behavior, and then they compound and cause flakiness. So sometimes if the flakiness is just too high, you should be asking, is this worth keeping this test on, right? The test has a certain benefit, which is it catch some problem, but if the cost of maintaining the problem or that the flakiness that it creates is too high, then it could be that the price is too high for the benefit, and then you should be throwing this test away. But again, some of the teams have done a lot more, which is so this is done by GitHub. You can see the logo here. So what they did was quantify the impact of test failure, the flaky failure, all the way. So they said something like, okay, they compute this thing called impact score. And I don't know how they come up with a number, but they could say things like, okay, this flaky failure has affected 2,700 bills. and it created a delay in the 37 deployment. So all of that is to try to quantify how painful this flaky failure is. And like I mentioned, if the flakiness is unevenly distributed, that's a great way to sort of help you focus on the right thing. And also, again, they're appealing to the managers, right? So the slowing down the 37 deployment is a better like a metrics than saying, oh, like I know this flakiness is really annoying, which is a qualitative information that doesn't move these people. And they even try to kind of diagnose the problem by saying, okay, like this test is just touched by this person, like who modified the code. So try to pin the blame down to a specific person, at least to begin the investigation, so that it doesn't become this collective team exercise, which when the blame is shared by the whole team, then nobody is really responsible, right? So I just think about like how much effort did they spend in building a system like this? Like, can you imagine like somebody in your team, let's say, I mean, it's probably going to take like 1/4 at least building this web app. And then not to mention all the data collections and computation behind the scene. So, well, to think that even GitHub has a flakiness problem to this extent to justify some of the engineers to spend this much time is both encouraging and depressing about the state of the software engineering. And then there's Dropbox, which is something I thought is really clever. So they have this like a system built around sort of like getting a lot more information about the flakiness. So what happens is when they first time see a test failure, they put the test into this noisy test state, meaning their system hasn't determined if this failure is caused by the flakiness or the legitimate problem. So usually, like, in most teams that I worked with, this state, like once the failure observed once is enough, that get escalated to developer right away, right? But they don't do that. What they do is this automated system kicks in, and they start running this test, let's say for multiple times. They sort of check out the earlier code and try to run the same test to see if some of those would fail. And then basically like using more information, determining either the test was indeed flaky, in which case the test is marked as quarantined, and then the developers are notified that, oh, this test is potentially problematic. And obviously the change that was flagged by the failure would be allowed to pass in. Or the code was determined to be bad, in which case like a proposed change gets rejected, reverted, and the test stays okay. So the fact that they built this kind of system to almost like a triage before the developers are asked to look into this is like a great first-line defense, right? They are trying to shield the developers from dealing with this lower-level analysis. And I feel like throughout our history of automation in the software engineering, that's kind of basically what we're trying to do, right? Like shielding the developer away from all the lower-level details. So they have built a system just like that. Now, what I'm really curious is, as I was hearing all these stories, like, okay, so are they, once the developers heard about this level of information, like, what are they doing with this information? Like, are they at the end of the day still just throwing the test away? Then, like, what's the point of all this building all these systems? That's something I love to ask these people building the flakiness tracking system in GitHub. And then the last bit that I couldn't quite fit into any of these one of the 3 pillars, but nonetheless, this is the approach that I love the most, is the more architectural approach to dealing with the flakiness. In other words, like, change the product itself so that it becomes more testable. Airbnb guys developed their whole a mobile application framework with the testability designed from get-go, right? So the mobile app, like one of the hardest things to test because it's got the stateful transitions, like interaction with the server. So originally they were doing things like the rest of us, in which case like they mock up the server, they simulate the people's interactions, and they see if the app lands in the desired state or not. But just like the web apps using Selenium is flaky, this kind of test is just so inherently flaky because it's testing like a big thing. So they kind of looked like a React native idea transposed into, or maybe they just wanted to build their own framework, whatever. But this was so they made the testing so easy, and then as a result, so they tame the flakiness in that way. And I'm more in the Java developer land, from old school guy. So early on, like maybe 10, 20 years ago, in the server-side Java, the whole programming paradigm called dependency injection was invented, in part because that was deemed more testable. So when we say, DevOps, like we like to say, well, devs and ops, like, they join together, we love each other. But when the testing became part of what the software engineers do, then it really changed the way we write code, right? So this is kind of key example of that, which I wanted to mention. We should be having more of those, but we don't. So yeah, so the main approach I mentioned, as I said, the 3 legs to the stool is keeping the builds green, and then the measuring the flakiness and escalating flakiness. So now how do these things, so where do we go from here? What's up next? So after I'm seeing these different teams take on this problem in different ways, I started to notice that the certain trend, which is there's almost like the thing is splitting into 2 parts. The one is inherently local, like a unique to every development team, which is to be able to run the test against the code in their setup. So most of the build pipeline that I've seen kind of intermixes the build and test together in ways that it's hard to just run the test, right? But in order to do any of these sophisticated approaches, it's kind of key to be able to test arbitrary version of the software against the arbitrary test quickly. And then so that requires some surgery into delivery pipelines. And then so that's something like unique to the development team. Often the environment that you run the test is all very unique and not portable. Then there's this other part that's seemingly more universal. Like I mentioned, this Bayesian inference algorithm that the Facebook guys have developed. I can't imagine different teams be implementing that, but there shouldn't be a need to, right? It's just pure sort of like a data processing thing. So if we can capture the test results in portable ways, and then build a common open source library or service or something, then that part, like how we process that data in more sophisticated, like a statistically sophisticated manner to extract useful insights, what I think of as a brain part, should be reusable. Right? So we shouldn't be having different engineering team in different company reinventing that. So if that's the reusable part, and if it's like running a test with a different version of software is the more local part, then it seems like that's the role split that we should be heading to. So I'm more interested in building this other side of the brain part, and then the tentacles that spread into your build and test environment. That should be that I think needs to be built locally. When I say by, I mean like as an industry collectively, we need to figure out the way to reuse that. So that's the kind of what I wanted to talk about.